process had ever been flowed that way.
When its 90 days were up, the team had torn apart this process and given one of America's oldest companies a radically simpler structure. Pratt's 50 business units, each manufacturing a small set of parts, would now be grouped into 7 separate mini-companies called product centers. Each product center responsible for a large family of engine parts. And company-wide departments, such as engineering, purchasing, and quality assurance, would be broken up and their people put into the new product centers.
So now you've got an organization that has everything it needs to design the part, to develop the part, to process the part, to source the part, and to make and deliver the part. So now we've got a business.
In August of 1993, Pratt & Whitney's old factories opened their doors on a new era. People who for years had worked apart were brought together in the new mini-companies called product centers, truly integrated factories.
Cluster assembly. Right now, it looks as though the print gives us a basic dimension as to how to locate the ring segment, which is fine in itself. But the problem is, we found that these two services truly aren't parallel.
Before product centers, Tony Perrone, a manufacturing engineer, and Gil Wilcox, a design engineer, worked in separate buildings and rarely met.
In the past, we used to have to call an individual on the phone, wait for him to get back to us, and then it was a matter of trying to explain to someone, you know, what you're trying to do and why, and it was just hard. You didn't have a part in your hand, so there's no visual representation of what you're trying to get at. Now, generally, we have an answer within a couple of days as to what we can and can't do.
Oh yeah, you can see it now.
You can see where the two services meet, and again, at the basic dimension, they're parallel. There is actually an angle there.
That'll solve the problem, right?
Yeah, that will solve the problem. Today, I sit right out on the production floor, so I'm right there. If anyone needs me, if anyone has a question on the product, I'm right there for them. And that in itself makes me much better in terms of servicing the shop.
Bringing people together was a first step. But if the new product centers were going to produce parts quickly, Pratt's re-engineering efforts could not stop there.
During this time period that the product centers were going in, we had to dramatically increase the speed and quality on the shop floor.
Before re-engineering, Pratt's machinery was scattered in clusters throughout its factories, each cluster made up of a few identical machines. Since parts require several different machining operations, they would be shuttled from one machine cluster to the next, a process that ate up a lot of time.
This part traveled, on average, 2 3/4 miles. And what happened is it went out of the control of the people that were responsible for this part many, many times.
In the new product centers, these clusters of identical machines were broken apart and regrouped to form small chains of different machines called product cells. These new product cells can quickly produce engine parts in a simple, continuous flow.
This is a vane cell. This is one of our 40 product cells that we have. A product cell starts a part at the very end of the line. It travels down this end, and you can see 50 feet later, the part is completed. So womb to tomb, start to finish, in a very short distance. Before we did this, the part was traveling about 20,000 feet per part. Within this product cell, it's about 1,000 feet that the part travels today. So 19,000 feet eliminated.
Before re-engineering, Pratt made hundreds of parts at the same time and stored them in inventory. Now, workers in the new product cells produce only those parts that are needed by a specific customer. A system called one-piece flow.
With one-piece flow, with less inventory in the line, you can deliver more product. When parts get made and sit and wait for the next operation, that's waste. That's idle time. And very simplistically, if you put it, our business is easy. We borrow money to buy a casting, and then as quick as we can turn it into something finished that I can sell to Delta Airlines or United Airlines, that's where we make our money. The longer that takes, the more my expenses go up. So with one-piece flow, you don't have to have a lot of inventory in the line. You're always adding value to the piece that you have, and in fact, you deliver more product.
To keep this process moving, Pratt pays its people to train one another so that each person in a product cell can operate every machine.
Well, training is something that we all share among ourselves. And like, for instance, we'll have people that only ran, for years, only ran EDM machines, the little wire machines. But now that individual, I trained him on how to run a grit blast machine or a grinding machine. Then he have trained me how to run an EDM machine.
You know, you get to learn to run different operations, every operation in the department. This is what the cross-training is all about. So, you know, you're not limited to just that one particular operation. You can run them all now.
Today, Pratt & Whitney continues to move thousands of its machines away from the sprawling layouts of yesterday's plants and regroup them in the smaller integrated factories it believes are its hope for tomorrow.
We have had absolutely dramatic improvements in terms of the way work is processed, taking parts that had lead times of 7 and 8 weeks down to 2 weeks.
By re-engineering, Pratt & Whitney has cut operating expenses in half, work in process by 75%, and reduced defects per million by 2/3.
The feeling we have in this facility now is that we're a new venture business, that we're reinventing ourselves, and that the opportunities are absolutely endless. So I think that's essentially true of everybody in the building. They feel that way, that, hey, we're onto something new and different here, and this is really powerful.
Pratt & Whitney is a good example of a company that sees its business case for change and decides to take action. Now, not all of our companies are in that condition, or managers don't always choose to act that way. In some companies, there is a business case for change, but the choice is to just incrementally reduce the staff and capability over time until the company really loses its capacity and capability. And then there are some cases where the business case isn't clear, where there needs to be argument and debate and analysis and confrontation before real re-engineering can begin. Now, at Pratt & Whitney, there was also a change in the metaphor. And a change in the metaphor, a way of thinking about the business, can be very helpful. Here, it was a business that was once an engine manufacturer. Now we're a parts manufacturer, 10,000 parts in an engine. And driving from that new metaphor, that new way of thinking about the business, Pratt & Whitney is able to attack the fragmentation. 50 business units that now become 7 product centers. And it's just not an attack on the structural fragmentation, but it's the way work is done. A focus on a single part and how a part is manufactured, with an objective to reduce time dramatically, but also to reduce inventory levels dramatically, characteristics of real re-engineering. But there's one other characteristic here, and that is, in order to do this new work, this at times more complex work, but more interesting work, we have to retrain and re-educate the workforce.
In the surreal world of this 21st century factory, workers etch elaborate microscopic patterns on circles of silicon. The first step in the creation of integrated circuits, commonly known as chips, those magical miniature devices that power virtually every electronic instrument on the planet. This is Texas Instruments, an enormous conglomerate, making everything from guided missiles to pocket calculators. 60% of its business is here, in its multi-billion-dollar semiconductor division. But by 1990, that division was on a steady downward slide that threatened to drag the rest of Texas Instruments with it. The plan to save it came from a wild leap of imagination.
People that had been here in 1980 remembered what it was like being a winner. And we were viewed as the best in the industry. People looked up to us. We were bringing new technology to the market. We were viewed as the innovator of the integrated circuit. By the early 90s, people couldn't understand what happened.
For over 30 years, Texas Instruments had dominated the semiconductor industry, by mastering the production of commodity chips, basic to everything from garage door openers to simple computers. But by the mid-'80s, TI's customers were designing new, sophisticated products that were not assembled from commodity chips. Cellular phones and laptop computers demanded customized chips, special chips for each different product.
The customized portion of the semiconductor market was becoming the fastest growing part of our market. So a huge increase was going to be required in these products. And so the area that we had to be excellent in